This program is presented by the Fromm Institute for Lifelong Learning at the University of San Francisco. The Fromm Institute, keeping up with the times no matter when.
Lovely to be back with all of you, technological difficulties notwithstanding. And I'm looking around. I'm not positive. I recognize every face. There are 100 people in this class, but I think I also see some new faces. And I'll just say very quickly, uh, it's a joy to teach at Fromm. And part of the joy is the wonderful students and the opportunity that it presents to explore new topics, to kind of move outside of my areas of expertise. And then that's certainly what I'll be doing with you over the next 8 weeks. And so I want to be as clear as possible at the very outset. I will reiterate this when appropriate. I am not a computer scientist. I am not a technologist. I am not somebody who has spent their life thinking about, let alone working on AI. I am late to the game, new to the game, but nevertheless thinking a lot about it over the last couple years. And so with that warning in advance, part of what I like or really love about Fromm is that it allows me to explore things that I think are particularly important, particularly relevant. And we've done this together in a couple classes in the past. 4 years ago, I did a class on social media technology as the pandemic drove more and more of us onto Zoom and online. I wanted to look at that topic in some detail. And a year ago, I did a class with some of you on the nature of human thought, in part anticipating that it will be, in a sense, important to be as self-aware as possible about what makes us human as we begin to share the world with another kind of intelligence, intelligent machines. And that process is really quite advanced. In doing the research for this course, I realized that as early as the 1990s, artificial intelligence was working with banks and the postal service, reading our checks that we deposited in ATMs, trying to recognize our handwriting and read our zip codes that we put on our letters. That's when, by the way, barcodes started appearing on mail. And so we've been sharing the world with artificial intelligence for a quarter of a century now at least, and certainly in a sense longer than that. We wouldn't have got to the moon, etc., without computer technology. But the new kind of artificial intelligence, machine learning, machines that learn for themselves, is, I think, really only a little bit more than a decade old in terms of our ability to interact with technology that includes a machine learning component. And really, it's only about the last year, maybe a little bit more than a year right now, right? ChatGPT introduced in November of 2023, that we have um, been directly interacting with this technology, able to talk to it and listen to it, and in a sense, be in conversation with it. And this is, it seems to me, the most opportune time to really begin thinking about what this technology is, how it works. And I'm speaking in the singular. I should really be speaking in the plural, because at this point, the most advanced forms of artificial intelligence is really they present a suite of technologies that do several different things at once. So understanding how these technologies work, what they do, how they do what they do, and what it's like for us to interact with them, it seems to me to be extremely important. The opportunity here is to begin to think about how we co evolve with our technology. We don't just use technology and stay unchanged by that use. We have, over our long evolutionary history, been changed by language, been changed by writing, been changed by new economic technologies that have allowed us to live in much closer proximity to each other, urbanization, been changed by the printing press, and then been changed, of course, by digital technology. Each technological revolution or wave doesn't just open up new realms of activity, new capacities, new power to control our environments. It also modifies us. And I think it's obviously too early to know in detail how we're going to be modified by this new technology. But I think the imperative to try to speculate in order to anticipate what it is going to do to us is essential. Because if we don't, we're walking blind into a vastly transformed world. And in many ways, I think this technology is unprecedented in its power, including its capacity to change us. So that's a little bit about my motivation for, if you will, stepping out on a limb in order to have this conversation with you. My guess is, given where most of you are, that some of you know more about this technology and have worked with it longer than I have. I really want to be in dialogue with you. So, my expertise, to the extent I have one, is in philosophy and in particular in political theory. I am bringing those tools to bear on this topic. Whatever insights you have, please don't hesitate to share them. And I want to be as clear as possible at the outset. I'll try to reiterate this as we go through. I really want to be in dialogue with you. That is, I think, how lifelong learning occurs best. It's also how thinking occurs best. None of us, I certainly don't make any claim, especially on this subject matter, to have all the relevant information or all the answers. We will do best if we pool our insights together. So please don't hesitate to let me know what you're thinking whenever you're thinking it. Raise your hand or just unmute yourself. Dawa, you're still there, right? Maybe he's actually trying to let people into this. But I believe you can just unmute yourself, at least if it's the way it's been in the past. So please don't hesitate. So let me now go ahead, and those of you who know me know that I do tend to work with slides, and I've developed a set of slides for this class, which will they'll evolve as I get further into it. But having said that, when I am in the slides, I'm less able to see you in terms of your faces. So why I emphasize unmute yourself and talk, raise your hand, is because when I'm in the slides, I'm not able to see you very well. Now, I have, as you will already see, uh, I've been thinking about this topic for a couple years. I've been working hard on this course for a couple months. Over that time, I've decided maybe a slightly different title would be in order. I've put the title and the subtitle, and I've put the main title as Life of the Mind in the Age of Intelligent Machines. And by mind, I do mean the human brain and the way in which it structures thought. And so, how will our minds be transformed by our interaction with intelligent machines? In order to understand that, we need to understand a fair bit about how machine learning works, but we also need to understand a little bit about how our own thinking works. So, as is always the case, I've got a number of images on the board. I've got a painting I like by Edwin Tanner, an Australian 20th century artist, called The Board of Directors, and he has reconfigured the corporate power structure as a circuit board, right? And thinking about perhaps the potential to transform uh, power relations as a result of the change in our technology, I think is going to be extremely important. I've got Giuseppe de Ribera's painting of Socrates, and I've used this image with some of you before, but the idea that he is simply reflecting upon himself to understand himself, that in a sense, Socratic wisdom requires self reflection in a perhaps basically technologically unmediated way. There's an irony in this painting, which is Ribera is anachronistic. The Greeks didn't actually have mirrors with the technology that we have today. They used highly polished metal. That doesn't seem to be highly polished metal. And then I've got also the 21st century version of self reflection, the ubiquitous selfie taker. Finally, I've got the image from the Sistine Chapel reimagined, right? And who is the creator and who is the created, who has the godlike powers in the scenario in which we are regularly in contact with intelligence that we have created, but in at least important respects exceeds our own capacities. And then finally, a piece of graffiti from England. The image here is all painted on a wall, and the right text message supposedly: "There's no need for me anymore. Have fun with ChatGPT. God." Right, and so one of the questions that we will look at in this question this course is the issue of what uh, uh, is sometimes called dataism. Do we um, assign almost magical metaphysical powers to machines that have the capacity to crunch amounts of data that human minds simply can't handle? So, some metaphysical questions being raised at the outset. I want to give you a little bit of an overview of where we're going to go over the 8 weeks that we're going to be together. So, I plan on spending about 3 weeks on the nature of machine intelligence, artificial intelligence, from both a technological and a philosophical perspective. So today I'm going to introduce you to some core aspects of machine learning. I hope pretty close to the state of the art. It changes very rapidly, so one always worries whether one's kept up with the cutting edge. But I'm doing my best to present what's going on, for instance, in large language models and other forms of machine learning that seem to be really driving exponential increases in the capacity of what machines can do when they learn, when they think, and then to introduce you to some of the concerns about the rapid development and diffusion of this technology. Next week, I'm going to look in detail about two issues that seem to me to dominate the conversation about what we should do in relationship to machine learning. One of them is containment. Can we keep it in a box? Can we unplug it or shut it down if we decide that we don't like what it's doing to us, or if it seems to, in some way, escape our control and start doing things that we don't want it to do? And I give you the answer in the very first three words of the um, title of next week's lecture. I don't think containment is possible. And I'm following a large number of people and thinking about this. It is too broadly diffused, and we are too reliant on machine learning, artificial intelligence already, and the channels via which it can escape our control are too many and too diffuse for us to anticipate and try to contain. I don't think governments probably can do this, certainly not without some sort of global consortium, which obviously we don't have at the moment. So, if containment is impossible, what about alignment? And alignment, sometimes called compatibility as well, is a term of art that's used to express the idea that we want a AI that does what we want it to do, right? We don't want it to do things that we have not directed it to do, or that do not align with our values, aims, and interests. And the issue here is not only, and we'll get into this, that the idea that all human beings share aims and interests, and as well as values, does not seem to be particularly plausible, right? And so please note that the good people of North Korea and China and Russia and Iran are working with and developing this technology. And obviously, their interests don't always align with our interests. But it's also the case that a lot of people who are developing this technology have a fundamental interest in making a profit. And very often, what is required to make a profit, especially in this realm, and we're going to talk a lot together about the increasing struggle to control our own attention, our own direction of our focus, what we do with our minds, right? That this is one of the essential frontiers in which artificial intelligence is being employed to do things that frankly could never be done before in terms of the manipulation of human attention and behavior. So even if it's not some bad actor in the sense of some hostile nation or some terrible person trying to use this technology to directly harm us, what if it's just a corporation that's trying to do what maximizes its shareholders' profits? And that doesn't align very well with what ordinary people want. And then I think we have to also consider, and I want to be as clear as possible. Very often, when you start speaking about this, a fair bit of what you talk about sounds an awful lot like yesterday's science fiction. But yesterday's science fiction appears to be very much tomorrow's reality. That'll be one of the fundamental takeaways of this class. What if artificial intelligence begins to develop its own intentions? Or what if we program it with intentions? And I want to be as careful as possible. A lot of this is not programming, right? Machine learning means that the machines teach themselves. But what if we design it, engineer it in ways that give rise to intentions, purposes, aims that we think we want until we realize, wait a second, it's taking us too literally. It doesn't understand the parameters of what we've thought. It's out of our control and doing things we don't want it to do. So that's a second range of problems. This will get us into differences in ontologies and intentions, right? Ways of thinking about the world, ways of determining how we want to act on the world, and why, if machines have different ontologies and intentions than we do, that may matter for our capacity to align with machine technology. Um, the third week again gets into the somewhat speculative, future oriented topic. One of the things that we're going to talk about as we get deeper into this is the apparent exponential growth in the capacity of artificial intelligence. And if artificial intelligence continues to develop at the rate at which it is currently developing, and if that allows it to scale, as computer scientists say, to not just get faster, but to do a much broader range of things, do we eventually get artificial general intelligence, not just a really good program for producing words or recognizing facial images or producing music, or and we could keep going, generating creative images, but a capacity for more or less doing everything that we do. We tend to be very anthropomorphic in thinking about what intelligence is. Um, and if it gets to be not only capable of doing the full range of things that we do, but better at us in doing many of those things, we may get to the point of super intelligence. That is to say, AI that simply exceeds our capacity for reasoning and problem solving across a whole range of domains. And at that point, we're not just sharing the world with an intelligence that may, in certain respects, exceed our own and wondering whether we align with it. We're sharing the world with an intelligence that clearly dominates our intelligence. Something
No problem. Thank
with,
you.
oh, well, thank you, and sorry for the interruption. Um, I really have no idea what happened, but I'm glad that I was able to get back in. It took a couple minutes. So let me continue right where we left off. Give me just 2 seconds to get everything set up on my end. And so we were talking about the course outline. The first 3 weeks are really going to be focused on the technology, its present and its likely future, and some of the issues that prevent us from simply treating this technology as something we automatically control. The second unit of the course is going to detour in a sense and focus on human intelligence, human learning, human reasoning. And as you'll see with week 4, I have actually got a long list here: intellect, reason, judgment, will, and emotion. And I say some commonalities and accounts of the capacities of mind that make us who and what we are. When I say some commonalities, anybody who knows a little bit about philosophy of mind, and we've talked about some of these issues together before in recent Fromm classes, knows that there's a great deal of controversy over how to characterize consciousness, intentionality, sentience, emotion, the things that make us who we are. My aim in this week is not going to be to reprise an entire course on the philosophy of mind, but merely to try to present some of what I think are the common intersecting or converging accounts of what makes us who we are. We're going to see, and I think this is going to be one of the central themes of this class, that many of the things that are characteristic of human reason, thought, what I'm calling the life of the mind, are uh, hard to ascribe to machine intelligence. We could start with the fact that we're embodied and have sensation. We can add to that the fact that we mature in a process that involves both physical and psychological growth occurring simultaneously, that we start our lives um, at, and in a way that is right, incredibly helpless, and slowly develop the capacity to navigate the world, to think for ourselves, to slowly begin to set our own aims and accomplish our own purposes. And none of that is characteristic of machines, right? And so the idea that they would be similar to us in these capacities is both not supported by what we understand about the way in which they operate and what we understand about the way in which we are structured, the way in which we navigate our mental life, and also not, if you will, supported by the hardware. Ours is rather different than the computational hardware of machine intelligence. And then if we turn away from philosophy to psychology, and in particular, examine, if you will, some of the routines and algorithms of the human mind, if I can use computational metaphors for a moment, I think we begin to maybe think, well, wait a sec, should we be so confident we have conscious awareness of a relatively limited range of the operations occurring within our brains? There's a whole bunch of stuff that happens that we are blissfully unaware of in our brains. If we became more aware of that as brain science advances, as our knowledge of brain science advances, will we begin to say, wait a sec, maybe some of the stuff going on that I'm consciously aware of supervenes, is dependent upon unconscious processes that look a little bit more like computer processes than we had realized. So with that detour, right, with a kind of, you know, uh, ambivalent understanding of what makes us apparently different, but also perhaps not as different as we think from computers and machines that learn, we return in the final unit to consider what it's going to be like to share the world with intelligent machines. And I obviously cannot anticipate all aspects of what I'm sure will be rich, complex, tangled, difficult policy issues, but also existential issues as we begin to share the world, really for the first time in hundreds of thousands of years, with creatures that have apparently a level of intelligence that is comparable to our own. And so I focus on three topics here. One of them is the way in which we're going to understand ourselves. And so one of the ways I would express this, borrowing from a contemporary philosopher's forthcoming book title, is that AI is a mirror. AI, in part, is going to provide us with vocabulary, with metaphors for interpreting ourselves. And one of the things you may have heard me say in past classes is that I do think we are self-interpreting animals. As our vocabulary for expressing our capacities and potentials changes, so actually do our potentials and capacities. We don't just neutrally observe ourselves, we bring into possible existence different capabilities and potentials through the way in which we talk about ourselves. And clearly, as we share the world with intelligent machines, the machine based metaphors, the computational metaphors. A moment ago, I asked your permission to talk about the algorithms and routines that are generating what we are conscious of, but that we are not conscious of. Already, right? I'm using a metaphor borrowed from computer science to talk about the human mind. In one sense, right, it's not at all clear that we have algorithms, though many people working in the contemporary cognitive sciences use that language. Um, do we know for sure that our brains and minds are structured in this way? Or is that a convenient metaphor to understand ourselves? How much will we reshape our overall vocabulary for self interpretation as we spend more and more time interacting with intelligent machines? So that's the first uh, topic. The second topic is going to drill down on a few uh, what I think of as essential, I'm calling them structuring commitments. And the question is, will we, or to what degree will we, sacrifice some of those structuring commitments in order to be able to use intelligent machines? And here I'm thinking of autonomy, our capacity to direct ourselves, to make up our own minds. And I'll just point out to you, right, how many of the books you've read in the last few years have been suggested to you by uh, let's take the easy example, Amazon's algorithms. How many of the articles that you've read have been suggested to you via, and then we could talk about Twitter or Instagram or Facebook, but also via Google or the New York Times, right? If you're reading the New York Times online, an algorithm is in part determining what you're encountering based on what it thinks somebody like you likes when you read the newspaper, right? And so how much of our capacity for directing our own attention, for making our own decisions, are we going to surrender to artificial intelligence because it seems to do a better job, or because it makes our life easier, or because it's just so damn convenient that it's almost irresistible, right? And so I don't know about you, I very often now open my GPS system, not only when I'm going someplace I don't know and there, right, I have a choice. I could do it the old fashioned way. I could look up a map and try to figure it out and increase my geographic knowledge. But I also use my GPS very often when I'm going someplace that I already know the way, just to see what's the fastest way, or is there any traffic that I'm not thinking about? And lo and behold, pretty soon I'm just doing what the GPS tells me to do. That is sheer convenience, right? It lets me think about something else other than making sure I make the right turn at the right place. But it is surrendering a degree of autonomy over my decision-making capacity. That may be trivial, relatively trivial, although having spatial awareness may not be entirely trivial, but it's certainly illustrative of how quickly many of us have surrendered aspects of our decision making to technology that is frankly getting better but still imperfect. This technology is going to become much, much more powerful, and there are going to be all kinds of applications that we are not currently envisioning that will, in many ways, make life easier, quicker, maybe let us concentrate our energies elsewhere, but nevertheless diminish our capacity for self-control. Similarly, with privacy, with work and labor, with the stuff we do in our day-to-day lives in order to be able to reproduce ourselves, manage our lives. Intimacy and intersubjectivity, right? These are ways of relating to other people, right? Not everybody that you relate to are you intimate with, but how many people already spend more of their time with technology than they do with fellow human beings. And I'll show you some data on this. I think it's quite staggering. And the technology that we have right now is often incredibly frustrating and deeply flawed. It's going to keep getting better. And the capacity to simulate a genuine human relationship, but to also bypass some of the costs and difficulties of having to make compromises, have a meeting of minds, recognize your own flaws and failures, that another independent, autonomous human being who has self respect and demands that you treat them in accordance with that, that may be no longer necessary in the world in which some of our friends will be not fellow humans, but artificial intelligence. Will we surrender some of our effort to make the world comport with our interest and our aesthetics, right? This is one of the central human activities. And will we allow machines to increasingly, perhaps virtually, perhaps actually make worlds for us rather than making them ourselves? How much of our creativity do we outsource to machines? And I will tell you that Sarah Lawrence College, where I teach, is already teaching, and it has a very active arts curriculum, its students to use AI to generate their art. And I just think we have to be careful here. The border between what the human is doing and what the machine is doing is very blurred, I think, at this point in a lot of AI art. And then finally, returning to this question of whether or not we will eventually have a world of superintelligence, what kind of attitude might we have to being superseded by our own machines? And then assuming that there's a world in the not too distant future where we're going to have to cohabitate it with machines that are, in many respects, more intelligent, more capable, more powerful than us. How can we regulate those machines? Can we regulate them so that it will be beneficial for us to be sharing the world with them? So I hope that makes sense. That's my overall plan. Let me go ahead and start jumping in. In about 5 minutes, I'll give us a little break, but I know we lost a little bit of time, and so I want to try to get as far as possible. So the first idea that I want to talk with you about is just what machine learning is. Why are we talking so much about it? What's the fuss? And then a little bit more about its rapid development and diffusion. So I've got 4 images here. One of them, kind of the fantasy, the utopia of a machine that knows exactly what you want and provides you with exactly what you want when you want, gives you the flower that makes your morning, right? And then the alternative image, this, of course, from Disney's Fantasia, Mickey Mouse is the sorcerer's apprentice who charms the brooms, or I guess it's originally one broom, to carry the water for him so he doesn't have to do it. And pretty soon he's being overrun by the technology he's invented. And so does technology do exactly what we want it to do or not? Two other images, this more from classical art, Goya's El sueño de la razón produce monstruos, right? The sleep of reason or the dream of reason, right? It's ambiguous, produces monsters, and it's a wonderful image, but is it reason itself that in its dream is producing the monsters, or is it the fact that reason has taken a nap that allows the monsters to escape? I do think, right, particularly for AI, the idea that reason may be producing a monster that it cannot control is wonderful. scary, of course, but a wonderful way of thinking about this art. And then finally, Rene Magritte's "Not to Be Reproduced," the fabulous image of a man looking in the mirror and not seeing himself, but seeing the back of his head, and in particular, the idea that our intelligence can't be reproduced. The things that make us can't be fully translated from the cellular and the mental into the environment of silicon and circuits is, I think, really provocative and important to bear in mind. So let's then get into the question, why? Why talk about AI today in 2024? And I'll start with the idea that now is a little bit more than a year old, but that in November of 2020, I said 2023 before, it's actually 2022 with apologies. Uh, OpenAI introduced ChatGPT. Please note that they're about to introduce ChatGPT 5. So the iterations here, the new and radically empowered generations of this technology are coming every 6 months or 8 months or a year or even faster than that. But this is what's called a large language model, right? A system that generates original text, language, utterances, paragraphs, stories, songs, poems, and advertisements, of course. And when I say generates, and this gets us to this key idea of generative artificial intelligence, it's not cutting and pasting, it's not copying from something that somebody else has written. It is creating its own original and often unique content. It is, in this sense, apparently thinking for itself, if by thought we mean, among other things, that process that produces cogent and original language. This technology can do that. We have never had that possibility before. This is striking. This is a stunning development. And it's not just that we now have technology that can use natural human language in an original and generative way. It's that these computers, this technology, this machine has taught itself to do this, right? And so this represents the power of machine learning. And it does appear, we'll talk more about this when we get into the psychology later in the course, that we are unique as a species in the animal kingdom on Earth in our capacity to produce symbolically mediated communication, to use words that encode concepts to make sense of our world. And that in many ways, this has driven the evolution of our brains and our culture and our societies and ourselves, back to the idea that we are self-interpreting animals. Once we have this rich vocabulary for self-expression, we become different kinds of creatures. And this is true not only in the way in which we comport ourselves or the technology we develop or the kinds of social relations we have. This appears to be true actually in terms of our physiology, in particular in terms of the way in which our brain is structured and functions. And so Sundar Pichai, the Google CEO, calls this new technology as transformative as fire or electricity. There is a lot of hype in this realm, but I want to be as clear as possible. I don't think that that is pure hype. We will know better soon, but it does appear that what allows for large language models, what allows for ChatGPT and Claude and Copilot is a fundamentally accelerated breakthrough in machine learning that it seems to me, I would add, uh, maybe language or the written word or the printing press, that there are these few changes in particular in intellectual technology, in the technology that we use to store information, to process the world, that this is one of those fundamental changes. Um, this represents a new kind of computer technology, dispersed deep neural network computing, where we've stopped trying to, and we'll talk more about this in a moment, but to program, to tell the computer, do this at this juncture. If you get this result, then you face this fork and take that path. If something else happens, take that path. This is sometimes called good old-fashioned artificial intelligence, which involves a lot of programming. This is not what generated these breakthroughs. As opposed to that, dispersed deep neural network computing, where we essentially have come to understand aspects of the structure of the brain and tried to instantiate them in other media, in a computational environment, and then let the neural networks of the computers, which are often spread over thousands or millions of computers and layered in what we call deep networks, right? To do the learning themselves. And for a long time, this was thought to be a dead end in computer technology. And then around 15 years ago, with the advent of new levels of computational power and new amounts of data for computers to learn on, this approach very quickly took off. And it does appear that it continues to grow exponentially in terms of its capacity. And so I do think now is the time to be thinking about this technology. We'll have to talk more about large language models and about the different versions of them. I've got names you may not recognize on the slide because, again, this stuff keeps evolving. So Microsoft used to have Bard, now it has Copilot. Google used to have something. I guess Google used to have Bard, right? Microsoft used to have Bing. Now it's Gemini. Claude is from Anthropic. Everybody knows ChatGPT, I'm going to assume, from OpenAI. These are the big foundational platforms of user-facing machine learning. That this is the place we can interact with this technology in 2024. And they all have large language models. They all, and I recognize that that may be a placeholder, a black box for now. We will unpack that in the second half of class today, but have the capacity to learn, to speak, to translate, to code, to do things in languages both natural and artificial that computers couldn't do until very recently. Another aspect of this that I think is worth paying attention to is what's sometimes called the problem of interpretability. I like intelligibility because it sounds a little bit more normal, a little bit more like plain English, but the question is, do we know how these machines are doing this? Part of the difficulty here is that it's happening so quickly. But I think the other aspect of this is that it's what's called computationally irreducible. It's numbers all the way down. And it's very fast, very minute interactions between numerical values that produces ultimately language or other forms of machine learning. And we are just not fast enough, not quantitative enough, our memory isn't good enough. But even more important, even if we could somehow keep up with all the equations, it wouldn't make sense to us because that's not the way in which we think. And so it's the peculiar thing here, right, is many of these new forms of artificial intelligence can give you an answer to a problem. When I look at that scan, am I seeing a torn meniscus of the kind that warrants surgery or not? And that answer may appear to be highly reliable, better than a human answer. But if we try to figure out how the machine reached that conclusion, we may have no capacity to unpack it, to render it intelligible or interpretable. And so this is another aspect of the current moment. We've unleashed this tremendously powerful technology that we really don't understand how it works. The uncanny nearness of computer talk to human language. It's not just the computers, you can think of HAL in 2001, A Space Odyssey, seeming to have a human voice and some aspects of human emotion or intention. It's more than that. It's that they often seem to be genuinely and deeply manifesting the same emotions, the same patterns and habits of thought that human beings manifest. They really seem to be like us. Given what I've said about them being right, computationally irreducible, I think we should be careful in thinking that. But this is where we are in terms of having unleashed machines that seem to be very much like us in the way in which they communicate. Um, and why don't I actually hold off on the limits of what they're saying and what it represents? I can do that more fully a little bit later today. I know we need to take a little bit of a break. So let me go ahead and suggest we take our break. It is 5 past the hour. If we can come back at 10 past the hour, that'll give me hopefully enough time to make some further progress. See you in a few minutes. Still technically break. I have just a couple questions. First of all, because I was cut off and had to get back in, I think I lost whatever was in the chat from the first maybe half an hour of the class. So I don't know if anybody has any questions that they put in the chat that I was not able to see as a result. If so, please, if you don't mind, just share them now, either by putting them back in the chat or just unmuting yourself and asking the question. With apologies, it just looks like I can't go back and get them. That's one of the things I do on the break. And then the second thing I guess I would ask is this making sense? Are you with me? And so that'll help me to figure out, in a sense, what pace I should go at with this material. And I know for me this is new material. I imagine for many of you as well. This is stuff that you may not have a background in. So far, pace about right, level of technical vocabulary pretty good, or not? Let me know, please. Thank you, Paul. Yeah, thank you, Barton. All right. I can always rely on positive feedback at Fromm, but please, seriously, if there's anything that is raising a question or an issue, please let me know. Okay. Let me see. I think somebody put something in the chat. Oh, okay. Just another indication that so far things are working well. So, buckle your safety belts. Off we go. We've got to talk a little bit now, I think, about what AI can do. But before I get there, I guess I've got some questions I want to express and then just pose. Right. So we've got large language learning models, right? Um, are they just beginning to show their capacity? And in asking that question, right, I'll just point to you to an analogy that's sometimes used. I think it was in 2019 that Elon Musk said within a year or two, we will have fully autonomous vehicles, given how quickly the technology of auto assist and autopilot was progressing at Tesla. And lo and behold, here we are, right? I guess maybe 5, 6 years later, and we don't have it, right? And so um, yeah, so the question here might be, um, is it a uh, case like self-driving vehicles where it moves really fast for a while and then it hits some kind of ceiling or ledge and it plateaus. And so we don't know yet, but I think we have to assume, given what's happened up until this point, and our understanding of the limitations that self-driving technology ran into trying to navigate three-dimensional space in ways that involve being able to cope with things that are unique or hard to anticipate, that this is different from language learning. And so I don't know that we need to anticipate that it's going to plateau or that it will prove brittle in ways that cause it to slow down. So I'm coming out of the slides for a second because I did get a question in the chat from Miriam that I want to spend a moment on. And she asks basically, what is ChatGPT? Can you explain? And so ChatGPT is a user facing, it's actually freely available in certain versions on the web, large language model. And so Miriam, let me see, do I see you? I guess I'll just ask rhetorically whether or not you use Google. And if you use Google, you're using a search engine, right, that gets you to a whole bunch of web pages. And Google actually uses artificial intelligence to try to figure out, given who you are and what people like you, when you put into your window Japanese restaurant in south of Market, right? Are you looking for a restaurant to go eat at? Are you looking for a restaurant review? Are you looking for a place that delivers, right? You know, and we could keep going, but just to make it easy, Google tries to figure that out for you in the background using artificial intelligence, and then presents you with results that it thinks are the results that you're looking for. But what you have to do then is go on those links. And by the way, Google is watching and seeing if maybe it didn't get the right results. If you search again, or if the link you go on is 8 links down their list, it's learning how to better meet what you want when you type Japanese restaurant south of Market in your search engine. Well, with ChatGPT, you can say, can you please recommend a Japanese restaurant south of Market to me? And as opposed to it giving you a list of things that presumably humans have put on the World Wide Web to try to get you to eat at their restaurant, ChatGPT will actually compose a little report for you, right? If what you're looking for is a nice restaurant to go to and you care equally about the food and the ambiance, here are 3 choices. If, on the other hand, what you're looking for is a takeout that's relatively inexpensive but has good food, here's a few choices for you, right? And so you don't need to follow all those links. ChatGPT actually does, in a sense, the thinking for you and composes something uniquely tailored to you. Now, How it does that is what we're about to get into, but it's using a large language model. Let's see. We've got somebody in the chat. This is the danger of going to the chats, saying that they've used ChatGPT to draft emails. And uh, and so that would be another good illustration. And somebody else saying tools like ChatGPT want you to sign up for it free, but I've wanted to experiment and to but don't want it to take over my searches. And that's more of a technical question, Judy, and I think you should be able to do that. And so you can continue to go back to Google or Bing or wherever you want to go after you've experimented with ChatGPT. Um, uh, and Amazon Books has a first reads where it recommends books that you might like that are free. Yes, all of these things are exactly correct. Um, and I think it's just important to notice, right? And example I've used in the past is, for instance, your sink is leaking or your toilet is leaking, and you want to compose an email or a letter to your landlord. You can ask ChatGPT to do that, right? You have written an advertisement, but you want to make sure the grammar is good. You can ask ChatGPT to do that. It is kind of an all-purpose language tool that also knows a lot. And I'll just say a little bit more about this for a moment because I think it's interesting. ChatGPT is machine learning. It's based on a large language model, and so it was optimized. It was trained in order to be able to construct cogent language. But it turns out along the way, it also learned how to code and it also learned how to translate. It was not asked to do that. It was not trained to do that. But because the data that it was trained on contained that information, it happened to pick that up. And here I think the analogy with a child is very important, right? You know, very often a child learns a lot more than you wanted them to learn by observing what the adults around her are doing, right? And that turns out this is the same. Paul, go ahead.
Back to the issue of whether or not this language models will continue to improve a plateau. It seems, well, does improving mean that they'll just get better and better at the Turing test, or will they get to some level of language beyond human capacity? And is that really relevant? Because wouldn't it only be relevant on a language basis if it's if the language is mutually intelligible, and then we just have the machine's behavior to judge whether or not what they're doing is good or bad for humans.
Yeah, thank you for that question, Paul, and really I think interesting and important. And so I'm going to start with a example of a place where it might not plateau and that might matter, right? And so one language that large language models seem to be pretty good at is machine language or coding language, right? And one thought is that one of the main bottlenecks or areas that are that slows down the current development of computer technology is that humans do a lot of the coding, right? And so and you could say the same thing about hardware design, right? There's a kind of interesting debate going on right now about whether or not Moore's law, which says that the number of transistors available in an area is going to double every couple years, and that's going to increase computational power exponentially, is that law dead? Have we finally exhausted our capacity to double every couple years? By the way, it's not a law, right? There's nothing in the nature of the physical universe that says this is the case. It was just an observation that turned out to be highly predictive for at least 60 years. Well, if it turns out that computers or machines are better at designing the most powerful processing chips than humans are, that's certainly going to be relevant. Uh, and so one of the things, right, we're talking about here is not only will they be able to think much more quickly than we can think, right? And I have to be careful. What exactly does think mean? Maybe reason would be better, where reason is the capacity to solve problems, right? Not all thought is problem solving. A lot of it is very different from that. But if, for instance, we need to figure out how to take carbon dioxide out of the atmosphere, carbon capture, right? In order to save the planet from global warming. And it can think through some of the permutations of that problem much more quickly than we can. Yes, it matters that whether it's going to plateau, and essentially what we have is a pretty good personal assistant without having to pay more than $20 a month for one. And by the way, Judy, one of the things I think you might think about as you're thinking about playing around with ChatGPT or Claude or one of the other versions of this is, do you want to for a month spend $20? And then you'll see all the bells and whistles as opposed to the easy version. But so right now, I think the $20 version is a really good personal assistant, and maybe really good is too strong because there's so many limitations on what it can do, right? It can't really make a reservation at a restaurant for you yet, right? It can recommend a bunch of restaurants, but you got to still be the one who makes the call. So all of that to say, if it keeps getting better and better at coding, then it's going to start, and I think this is critical, right, augmenting its own capacities. So that would be one area. Another area would be if it starts pushing the bounds of scientific discovery. That would be incredibly important too. We're going to talk in just a moment about some of the scientific breakthroughs that have already been driven by artificial intelligence. And so, Paul, I hope I'm answering your question. I'm playing a little fast and loose. I'm not just talking about large language models here. I'm talking more generally about machine learning. But I think we can ask the question more generally, is machine learning on this exponential upswing where it's just going to keep getting stronger and stronger or not? Judy, go ahead. You're muted still. Judy.
Okay, so
there
yeah,
you go.
I'm ready. Okay, so one thing you haven't mentioned yet, I'm sure you will in the course, but of course, one of the problems is the base of knowledge that it's using. It's taking the internet, is taking all kinds of stuff. A lot of stuff in the internet is crap. A lot of the stuff has a slant and a point of view about all kinds of social and political issues, which could go into its decision-making capacity. And then, people just start accepting whatever it is, and don't critique it. It's sort of, could be problematic. And sometimes it hallucinates when it doesn't have an answer, it makes it up. So those are things as a librarian I worry about. I'm still working, even though I'm 75. And actually I'm going to a workshop today at 1:30, an online workshop from one of the libraries I work at, talking about the impact on academia, such as students in an English class having the thing write the paper for them, and then it doesn't cite where it's getting stuff from. Stuff with art, where like those art students are getting stuff from it and may or may not realize that it's stealing stuff from other people. There's the whole plagiarism issue. So there's a lot of other issues too. there may be a lot of wonderful things that could happen, but there's also dangers, and all of them need to be addressed, I think.
Yeah, good, Judy.
And I'm sure you're going to talk about all this stuff somewhere in there.
Well, I mean, and part of the problem is it's nearly limitless in its complexity and difficulty.
Right.
But yes, so very quickly, right? The way in which machines learn is by being trained and being trained on data. And so far, almost all of that data is human generated. And if what we're talking about is large language models, that they're learning how to use human language by being exposed to millions of examples of human language and then developing maps and associations between words. And the result, among other things, has been that it's very often proved racist and sexist, for instance, in part because so much of human language is racist and sexist. And in part, we've learned about some of the ways in which our language is racist and sexist, or the ways in which our racism and sexism are registered in our language by seeing what large language models do. But one way to put this is garbage in, garbage out, right? Or bias in, bias out. And with humans, we can try to encourage them to understand what is wrong with being biased, with prejudice, with hate. With large language models, it's much more difficult to get them not to perhaps eliminate some of the racist associations. So one of the things I love here is that Google Photographs, I don't know if this is still the case, but for maybe 5 years, would not use the label gorilla because it tended to miscategorize Black faces as gorillas, right? And so deeply problematic. And their fix was just to get rid of the label, right? Not to try to fix the underlying problem with the technology. And that's the difference between, it seems to me, learning and in some deep human moral ethical sense, and fixing a bug in a program. Paul, go ahead.
Yeah, what really hit me about GPT when I started using it was what we really had here was not some great miracle, but we had the proof of concept of an idea that you could get a computer starting with nothing to put together coherent sentences in English, grammatically correct, that made a point. And only when you start asking about the correctness of what was there do you had to stop and scratch your head. There's the very famous case of the lawyer who wanted a brief to submit to a court, and the brief looked perfectly beautiful, and it cited a couple of cases which were credible sounding cases, except there were no such cases that came from, no one could figure out where it came from. And when it was submitted to the court, someone in the court went to look up the cases, couldn't find them, and the lawyer, the law partner, almost got disbarred over it. So yeah, it's one of these things. It's a can help you write something, but if you don't do some fact checking, you can get yourself in a peck of trouble. And what I think this is kind of one of the points where you reach a stable point where you're not going to, it's going to take a lot to go further. And when I was thinking the same thing with respect to the self-driving cars, it's been a challenge to get a humanoid robot to walk across, or better yet, run across a randomly cluttered room without bumping into anything. But we learned to do that when we were 1 year old. And so where we get
Speak for yourself, Paul, but yes, no.
where we get into trouble is where we think that because we have done some amazing intellectual feat with the computer, we've taken something like, say, chess and reduced it to software, that things that are less intellectually demanding will be, at best, at worst, not any harder. Turns out that's completely wrong. The more primitive the thought process, the more primitive the physical action, the harder it is to capture in software.
Well, and so I'm going to introduce for a second, and I'll come back to the lawyer and the hallucination in a moment, but it's sometimes called Minsky's or Marevich's paradox, the two
Yes.
computer scientists who came up with the same term. And my paraphrase of this is, what's easy is hard and what's hard is easy, right? And so it turns out that beating humans at chess is not that hard, or at Go, which is an even more demanding strategic game. Once you have a certain level of computational power and you get the machine to play itself enough times, it figures out vast new realms of strategy that lead not just to it winning, but to people being amazed at a strategic option that had never occurred to them before, right? And so some of the really hard stuff that involves kind of brute computational power, that stuff turns out to be almost a cinch for this new technology. Some of the stuff that we totally take for granted, being able to reach for a glass and get it to your mouth, being able to walk across the room. The example I love is doorknobs, right? And so if you look around your room or the spaces you go, look at how many different kinds of doorknobs there are in the world, right? And we have latches and levers and knobs and all kinds of different ways of opening doors. And we tend to just figure it out, right? It's on a door, it's in the right place. There must be some way of manipulating it to get it to open the door, right? And it turns out that this is really, really hard for robotics and computers. And so I think part of what is going on here is, and it takes me a little far afield, I'll just be very brief in saying this, is a fair bit of the stuff that we do automatically, like walking, we're doing with routines that don't involve much conscious thought or explicit reasoning at all. But those routines evolved over the course of hundreds of millions of years of animal and then ape or primate and then human evolution, right? And so we have these deep routines that don't need to be represented as reasoning at all. We just do it. That are really hard to get to machines to learn to do. But we had 100 million year head start over them, right? And so maybe we shouldn't expect them to be learning how to navigate rooms without bumping into things in a year or two. I just, I think it's important to have that qualification. Phil, go ahead. Phil, I think you're muted.
Yeah, I'm just trying to unmute myself. So I guess my question is, do we know, or does it make a difference as to what these algorithms are trained on? I mean, if the algorithm is trained on, X amount, let's say the New York Times,
right,
or let's say a scientific journal, or let's say, whatever. But, if it's trained on Fox News and MSNBC, then we're going to get, two very, it's going to be different. So I guess the question is, do we know the source of its training, and is that important? And to me, it sounds important.
Yeah, Phil, thank you. And I think the background to this, right, is, and so I want to take, because there's also a question in the chat. If AI is number-based, why do biases exist? And so I'm going to have to get more deeply into this. But one of the ways AI learns language is that it assigns a number to every word in a language, right? And then it kind of maps those words in a virtual space. How closely associated with each other are they? And then uses that map to generate new sentences and feed forward paragraphs, books, and by the way, there are a lot of books on Google right now that are written by AI, and most of them are pretty crappy, to be honest. Even the ones that are just like technical, how to fix your car or what you should do when you're in Venice. But so if, and I'll use a standard example, right? You can ask AI to do kind of word equations. Man plus doctor equals woman plus blank. And it will put in nurse very often, right? And what it's noticed is in the human language that it's been trained on, now to come back to Phil's question, right, that man is typically associated with doctor in the context in which woman is typically associated with nurse. And so it reproduces. And by the way, you could say that's the sexism of the language, or you could also say that's the sexism of society, right? That we have steered women into certain careers and men into other careers. It's not just that we write about men as doctors and women as nurses, it's that we've actually pushed people according to sex into different kinds of professions, right? So the language, in a sense, reflects the underlying sexism. Yes, it gets coded into numbers, but those numbers are there to do work that ultimately results in the AI, the large language model, reproducing the sexism of the language on which it's trained. That brings me right back to Phil's question: do we know what they're trained on? And the short answer is yes and no, right? Yes, in the sense that we know what they're trained on is what's out there on the web and what they can gain access to, hopefully without infringing copyright law. But then oftentimes you got to end up in a lawsuit to determine whether their use is public use or not. But having said all of that, what's out there on the web is diverse. There's the New York Times, and there's the MSNBC, and there's Fox, but there's also stuff that is, some 12-year-old up late at night populating their blog, or if it's Meta that's generating their Facebook page with whatever ramblings seem to be appropriate to them at that moment. And then please note, more and more of the content on the web is generated by AI or by large language models. And so there's a feedback problem here. If the training data is not actually human generated, how good is the training data? Not that we're great at producing great training data, but generally speaking, we have a intuitive capacity about how to use language that doesn't require to be trained on a model. If the model's being trained on stuff that's generated from a model, then you get a really difficult garbage reprocessing problem: garbage in, garbage out, garbage back in. And so yes, Phil, I do think that the question you're after, how do we keep the data that large language models are being trained on, or other kinds of machine intelligence being trained on, sufficiently, and then I think in the first instance reliable, right? In the second instance, then we might start to bring ethical criteria in, not too sexist, right? Not too racist. And please note that there's this huge problem in this domain with so much of what's out there that they're being trained on is sexist and racist or ethnocentric, etc., that we end up with these problems. And so I can tell I'm not going to get much further today. I see two Pauls with their hands raised. I think the Paul who doesn't have a last name, so not Paul Claremont, was the first with his hand up. Go ahead. Still muted.
Okay.
There you go.
Another aspect of Phil's question on a more technical domain is it was discovered years back the algorithms have improved themselves, but this was in deciding the accuracy of an AI algorithm in diagnosing tumors. And, that's important. They say that these algorithms reach 90% of the accuracy of a human, diagnosis, human doctor. Well, it turned out that in this particular case, the algorithm had honed in on the fact that images with a ruler in them were more likely to have cancer than ones without the ruler in them. And so it was using a completely spurious criteria that was really raising the estimation of its precision. And that's one kind of danger that has to be looked out for. As far as biases being introduced to numbers, biases, I think, get introduced as soon as you introduce a value. That bias comes from an interaction of the data with what you want it to do, and so you set a goal like don't be discriminating when you read resumes. That's where bias will come in. If you're just toting up numbers, there's not going to be a bias, but there has to be a value input that so far is being input by humans.
Good. And the example, if I've got it right, of screening for skin cancer and being convinced that a lesion or a growth is much more likely to be carcinogenic if it's got a ruler next to it, because it tends to be the case that when doctors populate medical textbooks or medical databases with examples of lesions, they always put a ruler next to it because that's relevant to understanding how far advanced it is or how dangerous it is, right? That confounds the machine learning. Another good example of this is we do visual recognition and we try to get the computer to recognize animals. One of the things that turns out that the machine learning is looking for is the background in focus or not? Because when there's a picture of an animal, it tends to be the background is not in focus. When it's a landscape, the background is in focus, right? And so there are these things that work, but that nevertheless are not really what we're asking it to look for. But then I would point out to you another example of machine learning on medical imaging is looking at pupil scans, which is done for a variety of reasons to detect various medical conditions. And it turns out that AI discovered that it could infer or deduce sex from looking at pupil scans, and that it could do so with 100% accuracy. And doctors were very skeptical, actually a little bit blown away. And then it turned out that it's exactly right, that there are things in the structure of the eye and actually that are visible in terms of the blood vessels in the eye that distinguish the sex of the eyes. Doctors had never really thought that this was relevant or necessary. So some of this learning is not spurious, some of it is genuine, and then there's a question, is it important, right? And so some of us who are up to speed on this will know about AlphaFold, which is a Google DeepMind use of artificial intelligence to solve a problem in molecular biology that, had it been solved by a human, would almost certainly warrant a Nobel Prize. Right. And yet it's an AI that solved this problem. So again, I think some of this is like silly, why should I need artificial intelligence to tell me where to order my Japanese food from? But some of it is really incredibly productive and important. So Paul Claremont, go ahead, please.
Yeah, uh, one of the things that I learned in a conference that I zoomed in on a couple of months ago was this fair bit of practical success with what you might call not so large language models, which are around a specific topic, specifically one like the alpha folding, which is hard science and not matters of opinion in it, no social bias, no anything like that. But and then it's very good doing what computers are really good at, which is pattern recognition, pursuing combinatorial kinds of things down to a great level. And that's so that's an example of a very appropriate use of the technology. And that, for example, might be the way we could get at some approach to climate change that involves all of the different sort of disciplines that could make a contribution to the climate change problem.
Yeah, thank you for that, Paul. And I'll point out, so there's a movement on the part of some computer scientists to simplify machine learning. And it has some really important advantages, among them that it might be less inclined to hallucination. And so, Paul, last time you spoke about the lawyer that used ChatGPT to write the brief, and ChatGPT hallucinated precedents, made them up out of thin air, plausible sounding cases, complete with citations to the relevant statute book or court journal. And yet when you look them up, they don't exist at all, right? And so one of the things we run up against here is, in the first instance, that these machines are told to generate answers. And so if it doesn't have an answer, it often fabricates it. And second of all, that they appear to be disconnected from truth in a way that the vast majority of human beings are not, right? That the verifiability of what they're asserting is just one of many of the parameters that they're working with, not a decisive or regulative parameter as it is for human beings, right? And so yes, we end up with these problems. A simplified model, among other things, might be much less prone to hallucinations, and it might be much more intelligible or interpretable. We might be able to figure out not only that it got it right about how proteins in three-dimensional space connect to each other, which is then important for devising targeted medicine to attack mutations or diseases. And so really important breakthrough, but how it did that, right? Not just that it did that, but why. And if you're a patient being told to take a drug, at some level, you want to know not only that the machine thinks the drug works, but why the machine thinks the drug works. And so simplified large language models or machine learning processes have some of those advantages. So Judy and Paul, if I can ask you to be quick, we're running out of time. Go ahead.
Okay. Yes. So, okay, I'm not trying to be a naysayer here, because I do think with science and all kinds of things, AI has tremendous ability, especially since those people are going to be critiquing everything and checking everything and seeing if there's anything weird in there, right? But as a librarian who for 20 years taught information competency, which was way before any of this happened, I can tell you, and there are statistics, I don't know them off the top of my head, that most people out there who just search the internet, use their social media, or in their little info bubble, just get what they want and they believe it, and then they pass it on to a million other people. And we know that even in the last election, Russia had an impact on what people were getting that were untruths. There's been lots of fake news from all kinds of sources. And now China's getting in on it. And there's all kinds of things that, I mean, people just believe all kinds of wacko things, all kinds of conspiracy theories, etc. And people don't critique it. And so what I'm worried about is people using this for their everyday life, their everyday work, and not critiquing, not looking at things critically, not checking things. No sources are given, or like sources, so they assume it's okay, not checking those sources. But so many things, in so many realms, nobody is checking the sources. Okay, I'll shut up now.
Yeah, and I'm just going to point you very quickly.
And that's an issue, because it's been a bad issue. Now it's going to be way worse because of AI.
Yeah, and so I'll just point out that I was looking at a study from Anthropica, which is one of the companies that's really cutting edge on AI, and so they were trying to determine how persuasive AI is relative to human beings, and their most persuasive AI, which actually exceeded human persuasiveness in a way that really was highly constrained, right? One communication limited to 250 words. The most persuasive AI was the one that was allowed to be deceitful, right? And it makes stuff up, but it makes stuff up in order to persuade you that the thing that it wants you to think is the thing that has the best evidence behind it. And so there's hallucination, and then there's malicious use of AI, right? And so if what we're talking about is Russian interference in the 2016 presidential election, or in the Brexit vote, or Chinese interference in the Taiwanese elections, and we could keep going, right? And so using social media amplified by artificial intelligence to plant ideas that manipulate the outcome of an election. This is just going to get, I think, more and more prevalent, more and more sophisticated, more and more destructive in terms of its potential to polarize us, for democracies, for societies with open public spheres that don't close things down because we got a First Amendment, or because we need to communicate openly with each other, and it's impossible to tell what is in real time generated by a real person and what's generated by a manipulative machine. We're in a brave new world, or a scary new world, for sure. So thank you for that, Judy. You guys are pushing me in areas that I'm definitely anticipating talking about. Thank you for helping me preview it. Paul, probably last comment for today. Go ahead.
Yes, quickly. I agree with all those practical issues that you and Judy just talked about, but and at first it felt more getting into the fantasy, but not really, as humans hallucinate, and so the matter of truth, in the computer's mind, they have an alternate reality, and so their truth to them and their reality is not tethered to the physical world the same way truth in ours is. So there is a real possibility here that we're talking about real alternative facts, because we're talking about an alternative universe. And as we get closer to the ideal of some in the Silicon Valley of the virtual, the metaverse, virtual reality, that's really going to become more and more true. As we move interactions into virtual space, with avatars and such.
Good. And so in the outline, I pointed out that, and this will be what we focus on next week, that computers have different ontologies, right? And that's a fancy philosophical word for a sense of what there is in the world, right? And I also put intentions. Maybe I should put psychology, right? And so with the exception of sociopaths or people who have really retrained themselves to become con men, as we call them, right? Gendered term, maybe appropriately. The capacity for a human to knowingly lie is actually really difficult psychologically, right? We tend to have tells on our faces, in part because we're struggling to overcome the part of our psychology that says we should tell the truth, right? And it's probably rooted to the fact that we are deeply social creatures, and that being able to rely on each other in interpersonal interaction is part of what makes us capable of having complex social life, right? And so, you know, among the features of human beings is that we've got these big irises on our eyes, which lets us see where everybody's looking, right? Which lets us know whether people are paying attention, and maybe even what our intentions are, because we betray ourselves with our eyes. All of this to say that there are all these features of human beings that tend to make it hard for us to dissemble or deceive, right? And that's just not there. So it's not just that the machines have a different ontology, that they're working with a map of words and not a map of the world that presumably the words reflect, right? You know, and in some sense, that's a deep difference between the way in which we generate our ontologies. But it's also the case that we have a psychology that was programmed by evolution to make almost all of us truthful most of the time, and in a sense, not very good liars even when we try to lie, right? And then they're the machines, right? Who just don't have evolved psychology at all. And so the expectation that they're going to be truthful is a projection based on human psychology, not something rooted in the way in which the machines think. So yeah, so the further we get into this, the more we start noticing all of these differences. So I loved being in conversation with you today. The result is that I covered even less than I thought I was going to cover. This is my liability for those of you who know me. I will do my best to not go fast, but to make sure I cover a fair bit of territory next week, and I do need to, because I recognize that on the you know, the Pauls and Judy and Phil, they have presumably some background and some experience and some ideas about this technology. Not everybody is on the same page, and so I want to do a little bit more to try to actually unpack how this technology works, and then get into a deeper sense of, given the way this technology works, what we should expect of it, both in terms of what it's going to be doing 5 years or 10 years from now, but also in terms of how it operates and how that illuminates what it can and can't do, or what we should expect it to do. I had fun, as I always do. I look forward to continuing the conversation next week. Hopefully we'll have all the technological issues worked out, touch whatever that is, and then we'll be off and running from the moment we start next week. Take care, everyone. Great being with you. See everybody next week. Thank you so much.
Thank you, Professor. Thank you, everyone. See you next week.